Hi, I'm Alistair, and this is an electronic buzzer system I made that you can use to run live multiplayer quiz games. Now, when I turn the power on, the first thing that will happen is that a little theme song will play, and then all of the players' buttons will light up to show that they're active and the quiz is ready to start. So the host asks the first question, and players have to be fastest to press their buttons when they know the answer. Now, when a player presses their button, a couple of things happen. First of all, we hear a sound effect. Now, each player's buzzer can have a unique sound effect assigned to it. And then the player who buzzed in, their button stays lit while the others go out. So there's no doubt knowing which player buzzed in first. And at this point, all of the players are locked out. Their buttons are deactivated, so pressing them does nothing. So what happens next is that the player that buzzed in gives their answer, and the quiz host has to decide whether it's correct or not. Now, if they got it right, the host presses this button on the control panel. That awards the player a point, and it moves on to the next question. All of the players' buttons light up, which show that they're all active again. Now, let's suppose that on the next question, the yellow player buzzes in, but this time they get the answer incorrect. And in that case, the host presses this button instead. Now, that deactivates the yellow player's button, but it reactivates the remaining players' buttons to give them a chance to answer instead. So now green buzzes in, but they get the answer wrong as well. So now they're also locked out. And so on and so on. And this continues until a player gives the correct answer, or if none of the players answer correctly, or if they run out of time and don't buzz in at all, the host can press this button as before, which reactivates all of the players' buttons and moves on to the next question. So hopefully you can see this is a pretty common fastest finger first lockout system that follows the expected behaviour of almost all TV game shows, pub quizzes, etc. It's easy to customise so that you can add time limits for each question, you could deduct points for incorrect guesses, or display players' scores on an LED display. And in the rest of this video, I'm going to explain how you can build this system yourself. So these are 100mm diameter illuminated arcade buttons. You can buy them very easily online. I bought these ones from a seller on AliExpress and they only cost a few pounds each. I laser cut and painted these boxes to house each button, but you could also 3D print an enclosure or just drill a 24mm hole and screw the buttons down into a piece of wood. Now, if I remove the bottom, you'll be able to see the underside of the button, which has got the contacts from the micro switch and the bulb holder wired to this cable harness. Now, illuminated arcade buttons are generally designed to run at 12 volts, but I'm going to run this system at 5 volts. So I removed the LED that the button came supplied with and instead replaced it with this ultra bright LED, which has a 100 ohm resistor soldered onto one of the legs. Now, I recently made a video all about arcade buttons, so if you want any more details about these, you can check that out. And then this is the quiz host control panel. It's got two more arcade buttons on the front for indicating whether a player's answer was correct or not. And it's also got this large speaker that's used for playing the buzzer sound effects. Now, I salvaged this from an old arcade cabinet and it delivers quite a lot of oomph, but you can really use any speaker here. You don't need a lot of audio fidelity just to play a buzzer sound effect. And then on the reverse, you'll see that I've got an Arduino Nano, which is the controller responsible for running all of the logic of the system. It's mounted on a screw shield just for the convenience of attaching components. And I've also got some Wago connectors here just to enable all of the buttons to be connected to a common shared ground. Here we've got a barrel jack used to supply power. And then over here, I've got an MP3 player. This is a DY-HV20T, which plays different audio files saved on this SD card through the speaker when triggered by serial commands sent by the Arduino. And this is the code that's running on the Arduino Nano that actually runs all of the quiz logic. So start at the beginning, I'm including two external libraries, the software serial library to create a serial interface to the MP3 player, and then this library here which is going to contain the commands specific for the DY-HV20T player that I'm using. These other boards also use exactly the same command sets. If you've got any similar DY player boards, you can use the library that is located at this GitHub link to control them. They basically just have different wattage outputs, and some of them use SD cards, some of them use inbuilt flash memory, but they're essentially the same control chip. We've got some constants which are how you configure the system. So I've set it up for 4 players, and they're going to have their buttons connected to these GPIO pins, and the LEDs for their buttons are connected to these GPIO pins. So depending on which processor you're using, that will limit the total number of players you can have, because you need to have a pair of GPIO pins for each player. If you're using an Arduino, I think there'll be enough for at least 6, maybe 7 players. If you want significantly more than that, you could use a Arduino Mega, which has got plenty of GPIO pins available. I've then got separate pins for the correct and the wrong button that the host presses after a player has given their answer. This section of constants here, these all relate to the index files of the audio clip saved on the SD card. So this is file number 1 is going to play the intro theme music. I've then got a selection of different buzzer sound effects. If you want to assign the same sound effect to every player, you could simply have this array having the same value for every player, or you can have unique values instead, as I've done here. I've also got one sound effect for an incorrect guess and one sound effect for a correct guess. Then we get some global variables. So this player who buzzed variable here, this both keeps track of whether a player has buzzed in for answering the question, and if they have, which player it was. So it's initially -1, and -1 just indicates that nobody has buzzed in yet. If it contains any other value, so 0, 1, 2, 3, that will be the index number of the player who has buzzed in to answer the question. We've then got a couple more arrays to keep track of information about each player. The first one is whether the player is currently active or not. So that means whether they've been locked out for having made a previous incorrect guess for this question or not. Initially, at least, all players are active, so we've got true for every element in the array. And also what the current player score is, and they always initialize to 0. Then we create a soft serial object, and we also initialize a player object that uses that soft serial connection. So these are using pins 8 for receiving messages from the MP3 player to the Arduino, and 9 for transmitting commands from the Arduino to the MP3 player. You can actually use different pins for those if you want, and if you're using a more capable board like an ESP32 that has more hardware UARTs, you don't actually need to use the software serial emulation at all. You could use serial 2 or serial 3 here instead. So I'm assuming you're using a basic Arduino Uno or Nano here, so that's why I'm using the software serial interface. In the setup function, initialize a serial connection. This is just used for debugging, and you'll have noticed in the video at the beginning I was showing an output of when certain events happen, so when players buzzed in, and also just a little table to show the scores of each player. That's going to be sent through this serial connection here onto the Arduino serial monitor. We configure all of the pins, so the inputs that are connected to the micro switches and the arcade push buttons, the output pins that are connected to the LEDs in the bulb holders, and then the 2 inputs for the host to say whether an answer was incorrect or correct. And then we start the soft serial interface. So this is the secondary interface that's going to be used to send serial commands to the MP3 player. That always runs at 9600 baud rate. We call the begin method on the player object. We set it to one-shot mode, so we don't want to loop any sound effects. Obviously, we just want to trigger them as one-offs. We set an initial volume, make sure that there's no audio currently playing, and then when all of that has been done, we finish the setup function, so we will play the intro theme music, and SFX intro here was the constant we defined at the top that refers to the first file on the SD card. Okay, then we go on to the loop function. So the loop function just goes round and around and around for as long as the microprocessor's got power. And on every iteration of loop, what we want to do is we want to make sure that the host has not pressed the button that effectively resets the state of the players for the next question. So this would happen if, you know, they asked a question, nobody answered it, or, you know, if every player had buzzed in and got it incorrect, we kind of need to reset the state back to the beginning. So that's what happens when they press this button. When it reads low, which means it has been pressed, this is basically a poor man's debouncing method here. Rather than continually trigger this, if the host were to hold the button down, we only want to trigger it once when they press and release the button. So we enter this block of code here when it has been pressed the first time, but then if it is being held down, we only get as far as this line, and for as long as the correct button is being held low, so it's being pressed in, we do nothing other than wait. So effectively this section of code here, rather than being activated on a button press, it's being activated on a button press and release. And that just prevents it being you know, double counted, being triggered twice or something like that. So if this button is pressed and released, what we're going to do is reactivate all players. So we'll just send a little message to the serial monitor, and then we call the activate player method, calling the index number of the player we want to activate, and we will loop through all the players. Activate player itself is defined towards the bottom of the code here, and you'll see all that does is that sets the element of the player active array to true. It has a partner function up here which deactivates a player, very similar function signature, and all that does is set the player and the player active array to false. Okay, so that's what happens when the host presses this on any iteration through the loop. It doesn't matter what the other state of whatever's going on, that will activate all players again. So it's kind of like a reset button basically. Then the next thing we want to do is we want to check if any player has pressed their button. So that's this section here. What we do is we loop over all the players. We light up only those players that are able to buzz based on the value in the player active array. So if this is true for the player that we're looking at the moment, we will write a high signal to their LED pin. That's what's going to cause the LED in their button to light up. If they're not active, that means they're not eligible to buzz in, so we'll write a low signal. And we will also test that player active element in the if condition here to say that if a player presses their button down, so if that reads low, and only if and they are active and able to do so, that's when they are allowed to buzz in. And when they buzz in, what we're going to do is we'll put a little display on the serial monitor again. Notice that I do I+1 here. Obviously, all program loops in C, generally speaking, start at 0. They're 0 index based, but you don't generally talk about contestants in a quiz to be, you know, player 0, player 1, player 2. You talk about players 1, 2, and 3. So for any output that's being sent to a display or to the serial monitor, I'm simply adding 1 to all of the values displayed there, just so that we don't have this weird condition of referring to one of the players as player 0, because I think that might confuse people. Just add them up. We will play the sound effect that is associated with the player that buzzed in, and that was defined in the SFX buzzer array, which again we defined at the constants up here. So we play whatever the index number of the MP3 file on the SD card is for the player that has buzzed in. And then we set the player who buzzed variable to be equal to the index number of the player. Remember, this was -1 initially when we first initialized the code, and that showed that no player had buzzed in. If any player has buzzed in, we will set that to be the index number of the player. Then when we get onto this section, if player who buzzed is not equal to -1, that means that we know that this section of code has just been executed, so we know that someone has buzzed in. Well, what do we do when that happens? Now we need to change the light pattern on each of the buttons to only light up the player who buzzed in. So again, we loop over all of the players and we write to the corresponding LED pin a high value if they are the player who buzzed in and a low value if they're not. And that's done by this statement here. So if the player we're looking at the moment in this loop is the player who buzzed in, this statement here evaluates to true, which means that we write a high signal to their LED pin, but for all the other players, we're going to write a low signal. Okay. So someone's buzzed in, we've lit up their LED. What we now need to do is wait for the host to say whether their answer was correct or not. And we call that in a separate function here, wait for host input. This is defined at the bottom of the code, but it's actually very, very straightforward. This simply enters a loop here, and it loops round and round while true until one of the following things happens. Either the host presses the correct button pin, or they press the wrong button pin, and depending on whether they do that, this function returns true or false. Again, I've got this sort of a poor debounce delay here, so rather than this triggering multiple times for as long as the button is held, this section of code here is entered when the button is pressed the first time, but then it will loop through this section for as long as the button is held and only returns true when it's released. So the host input has to be a press and release rather than just a hold down. And this returns true or false, true for correct and false for incorrect, which is assigned to this variable is answer correct. So then we have two possible things that happen. If the answer given by the player was incorrect, well, we play the incorrect buzzer sound. We deduct a point from the array of player scores corresponding to the element for the player who buzzed in, and we output some more information to the serial monitor again. If the answer they gave was correct, well, kind of the inverse of that, we play the correct sound effect instead. We increase their score by 1 and we say a correct message. And what we then do is we reactivate all the players again, ready to answer the next question. Now, if we get to this section of code here, that means that either a player has answered correctly or incorrectly. So we're going to take this opportunity to update the score display. Now, for the example I showed in the video here, the score display itself is very simply just the output from the serial monitor shown in the Arduino IDE. But if you wanted to, this is where you could add your code to update any other display. You can have an OLED display or a nice big 7-segment digit display for each player. However you wanted to do it, you could add that logic into this section of code here. But I'm just going to create a simple formatted table. So I'll give the player numbers as the header of the table first of all. I'll pad that to 5 spaces long, just so that the table lines up nicely. And then I will loop over each of the scores, again padded to 5 so that this lines up with the corresponding player. And I'll print the player score element from the array here corresponding to each player. But yeah, like I say, you could make this as complex as you wanted to add a more sophisticated score display if you wanted to. And finally, the last thing we do is, having evaluated the answer given by the player who buzzed in, we now reset that player who buzzed variable back to -1 again, so that on the next iteration through loop, we are starting with a blank sheet, we're asking a fresh question, and no one has buzzed in yet. And that is all the code. So that just about brings me to the end of this video. Hopefully you found it useful, informative, fun, and hopefully you'll now be able to go away and build your own quiz system similar to this one that you could run for your work colleagues or at a school or at a fundraising event. It's pretty straightforward build. I'll upload the code and all of the resources I used onto my GitHub account, and I'll put a link in the description below so you can follow along. If you have any issues or questions as you do so, please do write them in the comments below and I'll do my best to get back to you. Or if you've got any suggestions for features that you'd like to see added in the future, do write those as well. If you want to see more similar projects to this one, do please like and subscribe to this channel. And other than that, I just want to say thank you very much for watching and I look forward to seeing you next time. Okay, cheers, bye.